Assalamualaikum and good day. So now let's look at the basic properties and rules for limits. Okay, let K and A be a real number, then limit K when x approaches A is equal to K. Because here we don't have any unknown x that we can substitute the value of A. That's why it remains as K. Okay, let's look at the first example. Okay, I will write example and why that it may apply. Okay, let's see the first one. We have limit x approaches to here is 4. Okay, there is no x where we can substitute the value 2. That's why here we have 4 back again. Okay, and next example, let's say we have limit x approaches negative 1. Here is let's say the value here would be 3. So here it is equal to 3. Okay, because there is no x where we can substitute the value negative 1. Okay, next. Okay, limit x when x approaches A is equal to A. Okay, because we substitute A in x. Okay, for example, let's say limit here, limit x equal to negative 1 again, sorry. And here is, let's say, x. So that means substitute negative 1 in x. We have, it is equal to negative 1. Okay, I just want to write it much better because it needs to be aligned. Okay, the way you write the limit. So the next example, let's say limit x approaches 2. 2 again. Let's say I use 4. Here is x. Okay, here is x. So that means substitute 4 in x. We have it is equal to 4 here, right? So next, limit x approaches 0 from left here for 1 over x and from right for 1 over x. Okay, I would like you to look at this graph. Okay, remember the graph for rational function. Okay, x from left, negative infinity. Okay, the graph is like, Allah Akbar. The graph is like this. Okay. Okay. Much better. Okay, as you can see from the graph, okay, when limit x approaches 0 from left, this is where x equal to 0. The y-axis is x equal to 0. Approaches from left, here is the function coming from left. Okay, that means the graph is going downwards. That's why the value is negative infinity. This one is fixed. Okay, and if this is another rational function, you need to draw and test. Okay, next, limit 1 over x when x approaches 0 from right. Okay, here is the function coming from right and the graph going towards upwards. Okay, so that's why it is positive infinity. Okay, it is positive infinity. Sorry for the hiccup just now. Okay, so next. Okay, let me explain a bit. Okay, the reason I draw the graph because let's say if you just let it be limit x approaches 0, 1 over x, it is actually does not exist. Okay, even though when you just substitute the value, it will be 1 over 0 equal to infinity, it is still does not exist. Why? Because here it doesn't meet. Okay, so here limit from left is negative infinity, limit from right is positive infinity, not the same value. That's why limit 1 over x when x approaches 0 does not exist. Okay, so next, suppose that limit of x when x approaches A is equal to L and limit gx when x approaches A equal to M. Then, okay, we have limit k of x when x approaches A is equal to k times limit of x when x approaches A, which is equal to k times L. Okay, for example, here, okay, for example, limit, let's say, I just write limit x approaches negative 2, and here is 3, because k is any constant, right? So 3x, it is the same as 3 limit x approaches negative 2 x, which is 3 times negative 2 equal to negative 6. Or you can simply substitute the value, okay, right away. That means from here, limit 3x when x approaches negative 2 is equal to 3 times negative 2 equal to negative 6. You don't have to factorize like this. Okay, this is just a formality for me to show you what's the meaning behind the basic properties. Okay, okay, next. Okay, for 6, we have limit fx plus minus gx when x approaches a is equal to limit fx when x approaches a plus minus limit gx when x approaches a, which is L plus minus m. Okay, because right now, for example, it's better for you to look for an example actually. Okay, let's say we have here limit x approaches 1. Okay, open the bracket. Let's say we have 3x plus 2. Okay, that means here plus. When there is plus minus, we can separate them. Okay, which means this is limit x approaches 1, 3x tambah limit x approaches 1, 2. So here it will be 3 times 1 plus 2 equal to 5. Okay, that's what it means here. Plus minus, it can be separated. Okay, or you can also do it, solve it directly. That means from here right away, 3 times 1 plus 2 is equal to 5. Okay, remember, I just want to explain you about the properties. Okay, that's why I separate them like this. Okay, next, number 7, we have limit fx times gx when x approaches a is equal to limit fx when x approaches a times limit gx when x approaches a, which is L times m. Okay, a simple example would be this one. Okay, since I will just show you one example. Okay, this one is, let's say, limit x approaches, let's say, 4. This one is 3x squared multiplied with x plus 1. So this is our function. Okay, it means here you can separate them. You can actually do it like this. 3x squared multiplied with limit x approaches 4, x plus 1, and it is 3 times 4 squared times 4 plus 1, which is equal to, okay, let me grab my calculator first. Okay, 3 times 16 multiply with 5. Okay, 3 times 16 plus times 5 is equal to 240. Okay, or you can actually calculate it directly from here. It is equal to 3 times 4 squared times 4 plus 1. And you will also get the same answer. Okay, I'm actually explaining you about the basic properties of limit. Okay, the next one would be limit fx over gx when x approaches a is equal to limit fx when x approaches a over limit gx when x approaches a, which is L over m, where m must not equal to 0, because when m equal to 0, it will be infinity. Okay, does not exist there. Okay, so let's look at an example. Let's say we have here limit x approaches, I just want to use simple numbers because this is just explanation. Okay, here is x plus 1 divided by 2x. Okay, so we can actually separate them. Like that. Okay, then you substitute the value. 1 plus 1 over 2 times 1, which is, the answer is 1 plus 1 is 2 divided by 2 is equal to 1. Okay, the same goes here. You can actually directly substitute the value 1 in x. Okay, okay, the 9 properties is limit root of fx power of n when x approaches a is equal to this one. It can be factorized like this, which equal to this. Okay, root of L n. Okay, provided that L must be greater than 0 because this is root. Okay, so okay, if n is even. Okay, and if n is odd, it can be negative because power of odd numbers. Okay, so right now, for example, let's say we have limit x approaches to 2. X approaches 2, root of 3. Let's say here is 2x squared. Okay, so it means here it can also be written as such. Okay, let me finish writing it first. Okay, that's it. Okay, next we substitute the value of x. Here it will be root of 3, 2 times 2 squared. Okay, which is equal to root of 3. Here is 8. And this equal to 2. Okay. Okay, and then the last one is this one. Limit fx power of n when x approaches a can also be factorized like this, where the answer will be L power of n. Okay, for example, just a simple example for you to look at. Let's say we have here limit x approaches negative, x approaches negative 1. And here the function is actually, let's say, 3x squared. Okay, so it means here it is equal to limit x approaches negative 1, 3x power of 2. Okay, and here it will be 3 times negative 1 power of 2, which is negative 3 power of 2 equal to 9. Okay, these are the 10 basic properties for limits. Okay, hopefully this video will give you a glimpse of what the properties are. Okay, thank you class for your time. Assalamualaikum.